Test, test, test. Oh, it looks like my microphone might be working now. Okay, Nathan, check to see if I'm live. And then check to see if there's sound because. What?
The delta math is just adding positive and negative integers, and it's one of the timed ones. And it says I'm 95% done with it. Oh, it's because I didn't beat the time.
Okay. Yeah, which is fine, which means the grade is 95. And if you beat the time, then I change it to 100, and you don't have to worry about it. Yeah.
So I can just keep it as is?
Yes.
Okay. Oh, yeah, I finished my missing assignments for the. Yeah, I didn't know they were missing because, like, it's been a while.
It has been a while. Well, hopefully we'll do a grade check today.
Sorry, it choked on there.
That's
for a minute
okay.
Oh, you're already hydrated. You already beat me
Why did you leave
Is there sound? Can you double check it real quick? Turn up your volume. Hi, why did you look scared?
Sorry,
I do.
I changed it myself. What do you want?
Did you mute it?
Can I use some forget
Hi, everyone. It looks like my app wants to update. I've already tried it, so I'm just going to hit cancel over and over and over again. Oh, my goodness. So mute yourself. All right, cool. So, Unit 10, exponentials and logarithms. So let's talk about what the exponential parent function looks like. Exponential parent function, oh my goodness. There we go. Exponential parent function looks like this. F of x equals b to the x. Notice that the variable is sitting in the exponent. That's why it's called an exponential. That b is the base. It's some number that you're going to see. And it's a constant number. So once we've put a number there, it will never change for that particular function. It could be a whole number. It could be a decimal. It's not going to be negative in and of itself. If we put a negative, it's going to do something to the function itself. Okay? If b is greater than 1, the function is an exponential growth. And is, I don't know what it is. And if it's less than 1, it's called an exponential decay. Hopefully this is familiar to you from Algebra 1, which is the first time that you would have seen exponential growth and exponential decay. It's going to have an asymptote. Remember that an asymptote is going to be a line that your graph approaches but never touches. And when we say graph, we mean the actual drawing of the f of x rule thing. Okay, so the asymptote is your asymptotic sibling that's playing the I'm not touching you game. Oh. That's an asymptote. Okay. You saw that in the last section where I was putting that dashed line. That line was the asymptote. It's not actually part of the function. It's not actually part of the graph. It is this invisible boundary. All right. Let's classify this as either a growth or a decay, and then we'll graph it. And after we graph it, we'll identify some key characteristics. Okay, remember that your recipe for exponential functions looks like that, where the letter B is the base. What is the base of this function? 2. Our base is 2. Looking at the information above, if B is greater than 1, it's a growth. If B is less than 1, it's a decay. Is this a growth or a decay? Why? Beautiful. It's an exponential growth because the base is greater than 1. I wrote it in math symbols. Would you please, please, please write it in math symbols and write it in English? Because on test, if I give you one of those constructed response, you may have to say this is an exponential growth because the base is 2, which is greater than 1. So make sure you write it in math and in English. I'll give you 30 seconds to do your writing. B means base, yes. Great question, thank you. No, that's my shorthand for because. I did put a line because I don't know, when I was in junior high and I learned how to abbreviate because that's how my teacher did it, so that's how I do it. And it's been too long. Yeah, and now it's habit. All right, let's graph this thing. We don't know yet what this thing looks like, so we're going to default to x and y's. Okay, when x is 0, what is y? Well, remember that our base is 2 and our exponent is the x value. So because my x value is 0, my exponent is 0. Thinking back to our rules of exponent, anything to the 0 power is 1. Very good. So when x is 0, y is 1. X is 0, y is 1. All right, there we go. All right, we need another x value. We can either go to the right and start picking some positive numbers, or we can go to the left and start picking some negative numbers. Which negatives? All right, -1. So that means 2 to the negative first power. X is -1. The exponent is x. Using our rules of exponent, whenever you have a negative exponent, it turns the base into a fraction and then flips it. So when x is -1, the base is 1/2, or y is 1/2. So it's right here. All right, shall we continue in the negatives? Shall we do 1 in the positives? Yeah. All right, so which one in the positives do you want to do? 3? Okay, so x is 3. That means we're going to go 2 to the third power. What is 2 to the third power? 2 times 2 times 2? 8. So when x is 3, 1, 2, 3, y is 8. 1, 2, 3, 4, 5, 6, 7, 8. Do we have enough points yet to see what's happening, or do you want to graph a few more? Keep going. All right, give me another value for x that you want graphed. 2. All right, my function says take 2 and raise it to whatever number you gave me for x. In this case, it's 2. Y is 4.